Hi, I'm Craig, and this is the first video in this series. Unlike my other videos that are aimed at non-native English speakers, this is going to be aimed at native speakers or native-like speakers of English, because it's a subject that's often misunderstood, and due to language barriers it could be even more misunderstood. So I didn't want to worry about the words that I used and have to use simple words when they may be not completely correct. So this series assumes that you know nothing about evolution, but are proficient enough in English to understand most of what I'm talking about. I'll explain what certain words mean, are primarily used within biology and science when necessary. So this first video is an introduction to evolution and to scientific theories. So I'm going to start with the word theory. Yeah. So with the word theory, now the colloquial use of the word theory means a guess, and at times that's a completely blind guess based on nothing, nothing but opinion, and other times it's more of an informed guess, but still a guess. And this closely fits with the word hypothesis, within science. Okay, and you make a hypothesis after an observation. So it's based on little to no evidence. For example, an apple falling from a tree, or you see things moving in a certain way, and you see the apple fall and wonder why things go down and not up. Is something pushing it? Is there some type of force? Does this happen? Does this always happen? And this is now a hypothesis. But in order to know if your hypothesis is correct or not, you need to test it. So you gather some objects, drop them from different heights without adding force. Then you add force, and you throw them down to see if they fall at the same speed or not, arrive at the ground at the same time, or float. Maybe you throw them up and make note of the same things. You may put an object on a ramp and adjust the ramp so it descends at different angles, or leave it flat. Suddenly accelerate an object or suddenly stop an object and see how it reacts, and then come to the conclusion that an object at rest will remain at rest, and an object in motion will remain in motion and at a constant velocity unless acted on by another force. And then you come to another conclusion, that the force applied to an object is equal to the mass of the object multiplied by the force. And you realise that when two objects interact, they exert equal and opposite forces on each other. These are known as the three laws of motion. The law of inertia, force equals mass times acceleration, and every action has an equal and opposite reaction. Okay? And Newton's law of universal gravitation, which states that every particle attracts every other particle in the universe with a force that is proportional to the product of the masses and inversely proportional to the square of the distance of the between the centres. So physics isn't my strongest area within science, and this video isn't about physics, so I'm not going to explain this any further, but I do recommend researching as much as you can. But these are laws because they're always true, although the law of universal gravitation doesn't work at the subatomic level due to the uncertainty principle, or at high speeds and high energies due to other variables. But they have been sent to peer review and have been tested by other independent scientists from all over the world. And the theory of gravity, on the other hand, is a theory. So does that mean it's just a guess? Well, no, it doesn't. The theory of gravity explains the laws that I've just mentioned and the other things we know about gravity. Laws generally do not change, and theories, on the other hand, are constantly amended. When we receive new information and evidence, they will change. So a scientific theory is the highest point you can achieve within science. Now, Newton's theory of gravity is good enough to be used here on Earth, but when we venture out into space, there are parts of the theory that break down and it cannot explain them. So we now need another theory. So our theory is updated, amended. Okay, that is when Einstein came up with, first of all, the theory of special relativity, and later the theory of general relativity. Theories are sent to peer review and are vigorously tested by other scientists. When they have tried everything they can think of to falsify the hypothesis and decide that they cannot disprove the hypothesis, then they present their findings in a scientific paper for others to check, and eventually it becomes a theory. And the scientist that had the initial idea or performed the initial tests often, but not always, but often wins a Nobel Prize. Now, I use gravity as an example because the general public generally accepts the theory of gravity. However, because the theory of evolution is often misunderstood, many people reject the theory because they simply do not understand it. They have either misunderstood or have been given false information. So my aim within this series is to give correct information and hopefully help you understand the theory of evolution. So what is the theory of evolution? In simple terms, the theory of evolution is the change of heritable characteristics within a population over many generations. So this means that any characteristic that is possible for offspring to acquire is passed on imperfectly, so it changes over many generations. It is not an exact copy. Think about Chinese whispers. There's an origin story for that name, but that isn't for this video. Or some of you may know it as the telephone game, whereby a group of people sit in a circle and one person just thinks of a phrase and whispers it to the person to the right. Then that person whispers it to the person to their right, and that continues until the last person who says the phrase out loud, and more often than not, the phrase is completely different by the time it reaches the first person due to small changes from each person, who are the different people are depicting a different generation in this analogy, and each person might get one word incorrect. Some may get everything correct, but after 10, 20, 40, 80 people or generations, the phrase changes, and the more people involved or the more generations, the more it changes. But remember, I said evolution is change within a population. Changes occur within individuals, but if those new characteristics are not passed on to offspring, then it isn't evolution. So using the same analogy, take 20 of these tests with Chinese whispers or the telephone game. Use the same initial phrase with all of them. When you get to the last person, write down the phrase and compare that with the final phrases of the other groups. Mix up the groups or mix up the final phrases and put the phrases back into the group or back into the population to acquire more changes. And the more this is repeated, the more changes you will find. So I will talk more about this in the next video in more detail. But until then, remember to like and subscribe, and if you'd like to learn more about this subject, then click in the link in the description and book a private lesson with me. I primarily teach English as a second language, but if you specify that you'd like to learn more about evolution instead, then I can help you with that. So I will see you in the next one. Bye for now.